Hi guys, Ian here. In this video, we are going to talk about scalars. A scalar is a quantity which only has magnitude, that is size or length. So a scalar is a quantity which only has magnitude, that is size or length. Now this might seem a bit confusing, but let me elucidate it with an example. Say we have two houses, house 1 and house 2. And say I travel a distance of some meters, say 15 meters from house 1 to house 2. Now this 15 meters is the magnitude. This is the distance that we traveled or covered from house 1 to house 2. And it does not tell us anything about the direction. It only tells us about the distance or the magnitude that we traveled. So this distance is a scalar quantity. Now even if I say I traveled 15 meters in 5 seconds. Now that would mean I traveled 3 meters per second, and this 3 meters per second is what we call speed, and speed is defined as distance by time. Now the speed itself is a scalar quantity, even if it has two measures such as distance and time, but it still does not tell us anything about the direction. So this is also a scalar quantity. Another example of scalars would be temperature. Temperature only tells us about the magnitude and nothing about the direction. Now let's talk about the mathematical operations that we can perform on scalars. Since scalars are just real numbers or numbers in general, we can perform mathematical operations on them exactly as we would on numbers. So they would look something like this. Say 3 times 3, which is 9. 3 plus 4 would be 7. And 3, or let's pick some other number. Let's say 5 plus, we did the addition part. Let's say 5 minus 2, and that would be 3. And likewise for other mathematical operations. Now we can also define scalars in terms of matrices as a matrix which has only one row and only one column. And we can represent these scalars as something like this. Normally you would just write the number, but in case of matrices you have to put these numbers inside square brackets, and that's how you represent scalars in terms of matrices. And as you can see here, it has only one column, which is downwards, right? And from left to right, only one row. Only one row and only one column. Now the mathematical operations that you can perform on these scalars in terms of matrices are exactly as we did in the previous slide. The only difference would be that we had to put these numbers inside square brackets, and they would look something like this. 3 times 4 would be 12. inside square brackets. 5 plus 8 would be 13. 8 minus 2 would be 6. The resultant matrix will always be inside square brackets, so it would look something like this. So similarly, you can perform other mathematical operations on these scalars. Now, this was all about scalars. In the next video, we are going to talk about vectors and how we can represent vectors in n dimensions. I'll see you in the next video.